So continuing on with multiplying radicals, we've got a few more complex examples here. The good news is the process is not going to change at all. We just may have to rely on some previous knowledge to get there. So in C, we actually have 4 terms, 2 sets of 2. So to multiply these, we will have to do some foiling. So just to go step by step with that, we do the firsts. So 8 root 2 times 9 root 5. 8 times 9 would give us 72. And root 2 times root 5 would be root 10. Then we'll multiply the 8 root 2 times the negative 6 root 10. So 8 times minus 6 is minus 48. Root 2 times root 10 is root 20. Insides here, minus 5 times 9 root 5. And this one's a little bit different because that 5 does not have a root attached to it. Actually, in a way, makes things a little bit easier. So we'll just multiply the 5 and the 9, gives us minus 45. And the root 5 that's attached to the 9 has nothing to multiply with it. So we'll get minus 45 root 5. And the lasts, we have the minus 5 times 6 to give us plus 30. And the root 10 has nothing to multiply with, so it'll just stay as is. We do need to look to simplify. So if we look at the terms we have now, 72 root 10, well, if we look to break down 10, all it's going to break into is 2 times 5, so nothing useful there. 48 root 20, if we have the root 20, that will break down, so we'll go ahead and do that. I'll just do that up here. So when we break down 20, we can divide it by 2. 2 times 10. We're sitting at 10. 10 is divisible by 2. It's 2 times 5. Pair of 2's to come out, multiply into the 48. 2 times 48 gives us 96. And we have root 5 left over. So just to go back, so 72 root 10 we couldn't simplify. We'll have minus 96 root 5. Next term we have is that 45 root 5. The root 5 can't be simplified anymore, so that one will stay as is. And 30 root 10, just like with 72 root 10, can't simplify that in any useful way. We do have some like terms now that we can combine. We have 72 root 10 and 30 root 10. Go back to the methods we looked at 6.2 when we're adding radicals. We'd get 102 root 10 out of that. And we also have negative 96 root 5 minus 45 root 5 to give us negative 141 root 5. Clear this off for example D. D is actually quite similar to B in the fact that we have to distribute out what does change though is we have cube roots. Distribute the 9 cube root of 2 into the 9 cube root of 2w into the cube root of 4w. The 9 has nothing to multiply with, so it stays as a 9. We have a cube root, 2w times 4w, 8w squared. Plus, we'll take the 9 cube root of 2w, multiply that by 7 cube root of 28. 9 times 7 gives us 63. 2w times w gives us 56w. As always, we need to look to simplify if we can. So we have 9 cube root of 8w squared Break down the 8, it's divisible by 2, 2 times 4, and that 4 is 2 times 2 itself. And the w squared gives us 2 w's. Apologize for having to squish that in. Things to take out, we need a group of 3 because we have a 3 as the index. We have 3 2's. Take those out, multiply them into the 9, which would give us 18 cube root of, and our leftovers are w squared. So the 9 cube root of 8w squared is really 18 cube root of w squared. Break down the 63 cube root of 56w. Break down the 56, can divide it by 2, it's 2 times 28. That 28 is divisible by 2, it's 2 times 14. That 14 is divisible by 2, and it's 2 times 7. And again, if you're not sure how to prime factorize in one step like that, go ahead and work through the steps. It'll just take a little bit more paper. You always have the double check. You can multiply the 2 times 2 times 2 times 7 and make sure that you've actually factorized it correctly. Need groups of 3 again to take out. We have 3 2's. Those can multiply into the 63, which would give us 126. Cube root of our leftovers, which are 7w, which we can throw back over here. Now this one is slightly different in that we do not have like terms. We cannot combine those terms at all. We have a cube root of w squared, a cube root of 7w. This question, this is as simple as it gets.